Welcome, our noble viewers, to Science and Spirituality. Today we have the unique opportunity to explore a particular view on how life in the universe developed with one of the world's most innovative and progressive biologists, Dr. Rupert Sheldrake of Britain. He is best known for his theory of morphic fields and resonance, which describes the unfolding, emergence, and evolution of the universe. Dr. Sheldrake studied biochemistry and other natural sciences at Cambridge University in England and philosophy at Harvard University in the United States before returning to Cambridge for a PhD in biochemistry. Currently, he is the director of the Parrot-Warwick Project, which is administered by Trinity College in Cambridge, England. The project's purpose is to research unexplained human and animal abilities. He is the author of more than 75 scientific papers and 10 books, with some of the most renowned being A New Science of Life, The Hypothesis of Formative Causation, Dogs That Know When Their Owners Are Coming Home, and Other Unexplained Powers of Animals. What exactly is meant by the term morphic resonance? Our Supreme Master television correspondent asked Dr. Sheldrake himself about the concept.
Morphic resonance is a kind of memory principle in nature. Anything similar in a self-organizing system will be influenced by anything that's happened in the past, and anything in the future that happens in a similar system will be influenced by what happens now. So it's a memory in nature based on similarity, and it applies to atoms, molecules, crystals, living organisms, brains, societies, and indeed to planets and galaxies. So it's a principle of memory and habit in nature.
And animals and plants, of course.
Oh yes, animals and plants. And in fact, Charles Darwin was convinced that animals and plants were essentially habits. And one person who's commented on his work, Francis Huxley, said that he could just as well have called his book The Origin of Habits instead of The Origin of Species, because for him, organisms are habits.
To provide further insight into Dr. Sheldrake's ideas, we now present excerpts from the lecture entitled Morphic Resonance, Collective Memory and Habits of Nature by Dr. Rupert Sheldrake, presented at Goldsmiths College in London, UK on January 20th, 2009.
The idea of morphic resonance has huge numbers of implications, and they're all rather shocking from the conventional scientific point of view. The first and biggest of them is that the so-called laws of nature may be more like habits. They're not all fixed. They can evolve. One of the implications of this is that all species, including humans, draw on a collective memory. Each individual draws on a collective memory and contributes to it. Another implication is that ordinary memory works by morphic resonance. They're not stored in your brain. Your brain's more like a receiver that tunes into memories across time. I'm hoping to show that these are scientific ideas that lead to a completely new way of looking at nature. The idea that the laws of nature are fixed is a very old idea. It goes back to ancient Greece. In the 17th century, the founding fathers of modern science, Galileo, Copernicus, Newton, all believed that science was in the business of finding out the eternal mathematical laws of nature, which were ideas in the mind of God. They were beyond space and time. They were not material because they were part of the divine nature. In the 18th century and the early 19th century, with the growth of atheism and materialism, the laws of nature remained there like the ghost of the mind of the God of the world machine. Changeless mathematical laws which determine everything that happens. There was this idea that history was moving towards a goal, and that gives the idea of progress. Progress literally means moving forwards. These progressivist movements were confined to the human realm until the middle of the 19th century with Charles Darwin's Origin of Species. An evolutionary vision in 1859, 150 years ago, was extended to the whole of life. Darwin hardly used the word evolution. He usually used the word progress. And so it was really an extension of the idea of human progress to all of life. But it stopped there. For most physicists, the idea that the whole universe was progressing seemed absurd. At that time, physics was in the grip of the second law of thermodynamics as a dominant idea, which said, in fact, the opposite of progress was happening. The universe was running down towards a final heat death when it would freeze up forever.
We will bring you more excerpts of Dr. Sheldrake's lecture right after these short messages. You are watching Supreme Master Television. Welcome back to Science and Spirituality. We are exploring morphic fields and resonance, an idea introduced by the British biologist Dr. Rupert Sheldrake. The idea theorizes that nature has a collective memory, which influences subsequent things on the basis of similarity of forms. If Dr. Sheldrake is correct, this means that the so-called laws of nature are not fixed and that our memory is not localized in our brain. We now provide further portions of a lecture entitled Morphic Resonance, Collective Memory and Habits of Nature by Dr. Rupert Sheldrake, presented at Goldsmiths College in London, UK, on January 20th, 2009. Here, Dr. Sheldrake continues his description of how the ability of the laws of nature to change has been perceived over time.
So, it really was only in biology that this evolutionary vision got going until 1966, when it took over physics as well. The Big Bang cosmology tells us that the universe began very small, less than the size of the head of the pin, very hot, and it's been growing, cooling, and evolving ever since. Now, all of nature is evolutionary. This vision, originally religious, then secular and social, then biological, is now cosmic. So we have cosmic evolution. Now, what about the eternal laws of nature in an evolving universe? Most scientists believe in the eternal laws of nature not because they've thought about it, but because they haven't. And this is where I think real skepticism comes in. Deep skepticism is to ask questions about things that most people just take for granted. These all share the idea the laws of nature don't change. But if the universe is evolving, why can't the laws of nature evolve too? As soon as you ask that question, you realize that the very idea of the laws of nature is questionable. If by law we simply mean regularities as discovered by science, then since the universe has evolved, the regularities in it have evolved too. And so we immediately arrive at the idea of evolving laws of nature. It makes a huge difference to the way we interpret natural phenomena. For phenomena that have been around for a long time, like most of the things physicists study, hydrogen atoms, for example, the formation of stars, salt crystals, these kinds of things have been around for millions or billions of years. If they have habits, the habits are now so fixed that you wouldn't notice any change. They behave as if they're governed by fixed laws. Where the difference shows up is when you look at new phenomena that have never happened before in the history of the universe. And there, we should be able to see the habits build up. Now, it so turns out that you can actually study this in chemistry. What do chemists actually find? They find that new compounds are very hard to crystallize, and as time goes on, they get easier and easier all around the world. Sometimes there are compounds that aren't known in a crystalline form at all for years, and then once they've appeared, they start showing up everywhere. This happened in the drug industry. It's happened several times when what are called allomorphs, different forms of crystals of drugs. One of them in the AZT, AIDS formulation. Suddenly, deviant crystals started showing up in a factory, and soon they were everywhere, and they couldn't get the original ones again. Suddenly it was like an infection. They'd taken over another form of the crystal. If the organizing habit of the crystal gets stronger as time goes on, even a fully crystallized substance should have a stronger habit, and it should be harder to break it up. To break up crystals, what you do is heat them up, and they reach a point where the thermal vibration destroys the crystal structure, and that's called the melting point. And everybody knows that the melting point of water is 0 degrees centigrade. So if newly crystallized substances become more stable, this theory would predict the melting point should rise. It took me a long time to pluck up courage to ask a chemist, have you ever noticed whether melting points of new compounds go up? To my surprise, he said, oh yeah, it's quite a common observation. I've often found it myself. It's quite easy to explain. He said there's no mystery here and certainly no morphic resonance. He said what's going on is simply that when you get better at making a compound, you get purer samples. Impurities lower the melting point. So as we get better at making things, they get purer, and so the melting points go up. But I decided to try and take it further by looking at historical records. This compound is salicin, and these are the melting points in 1932, 1902, 1940, and 1994. And salicin occurs in willow bark. It's a natural compound. No change in melting point over the 20th century. Aspirin is a synthetic derivative based on that, first synthesized in the 19th century. In 1914, middle of the 20th century, in 1994, it went up in melting point by about 14 degrees centigrade. We're not talking here of fractions of a degree, we're talking big effects. Well, this principle of memory in nature is what I call morphic resonance. The idea is that similar things influence subsequent similar things on the basis of similarity. They tend to make the same kinds of things happen again. So similarity is the principle, and resonance is the movement across time of information about patterns of vibratory activity, so that any pattern of vibratory activity, which all atoms, molecules, crystals, cells, organisms have, they're all oscillatory or vibratory, resonate with those that have gone before, across space and time. It doesn't fall off with space and time. It doesn't involve a transfer of energy, but of information. That's the postulate. Right or wrong, that's what I'm suggesting. And I'm further suggesting that in biological systems and in chemical systems, the pattern of things is organized by what I call morphic fields.
Next week on Science and Spirituality, Dr. Sheldrake will share more evidence on the existence of morphic fields and resonance. Please join us then. Thank you, inquisitive viewers, for your company today on Science and Spirituality. Coming up next is Words of Wisdom, right after Noteworthy News. May you have a wonderful week ahead.